Testing. 1, 2, 1, 2, 3, testing. Here we go. Take a look at our scene. All right. Are we working? Are we live? We are live, in fact. Okay. Hello, everybody. I'm Dan from Dan Does Data. Over the past couple months, I've looked at various machine learning libraries, looked at TensorFlow, looked at Theano. Today, I just found out Microsoft sort of fully open sourced their toolkit. Is my microphone not working? Hang on. No, we're good. Okay. Sorry about that. They released their own library called CNTK, and since it just got fully released today, I figured I'll try and do a video today. We'll see how that actually goes. They released some impressive stats showing that it's much faster at certain things than, say, TensorFlow or Theano. It also allows you to use GPUs over multiple machines, or multiple GPUs on one machine even. So that looks pretty impressive. I only have one GPU on my local machine, and it's like 4 years old. So that might not even be part of the problem. I probably won't even get to that point. But I want to see how challenging it is to install this and get it going. You might recall with TensorFlow, that took me a while. I had a hard time. With Theano, it took about 10 seconds. This will probably be somewhere in the middle. So this is sort of the main Microsoft blog release where they're talking about it. What do they claim that CNTK stands for? That would be good to know. Computational Network Toolkit. As I understand, it doesn't yet have Python bindings or anything like that. But it does, it's sort of a binary, and you pass it like a configuration file. That's sort of the code that you're writing that specifies your net. So we're going to be checking it out. I really like Python, but I appreciate that that's not ready yet, and they want to show people, hey, check this out, see how good it is. So they have a GitHub page. Here it is, github.com/Microsoft/CNTK. I really like that. I love the GitHub interface. It's super good. All right, we want to install and do the setup. Yeah, it's directed graph, leaf nodes, feed forward, deep neural networks, convolutional nets, recurrent nets, all the popular stuff. Stochastic gradient descent. Parallelization across multiple GPUs and servers. That's the big thing, that you can do this on a cluster of different computers. That'll really open up like a whole new order of magnitude of computing that you can do. If you only have your local machine, you're kind of limited. But if you've got many, many, many machines, all with lots of GPUs, you can get so much more done. All right, but we first just want to try to install it. A few pages to get you started. Set up CNTK on your machine. Let's do that. There's already 10 issues and already 2 pull requests. Jeez, I checked this like a couple hours ago. There was like no pull requests. Let me start this. Bam. Binary installation. So this means they've already compiled it, and hopefully I can use it relatively easily. Oh, there's some configuring. Okay. This is how you, instead of using Python, you're using this network description language, NDL. That's what we're going to do. That's cool. I want to try the simplest thing, so we're going to try the binary download and configuration. Windows and Linux 64-bit platforms. Yes, I checked that. As opposed to when I tried TensorFlow, and I didn't realize it was only for Python 2. I do have a GPU, so we're going to try to get the GPU version, but I don't have Windows. I do have Windows, but I do most of my development on Linux. That's where I'm comfortable, so that's where we're going to try this. All right, download and unzip from release page. Well, let's do that. There aren't any releases here. Interesting. Can I not do this yet? To download the binaries, go to the releases page. Oh, this could be interesting. Is it not actually available yet? Releases are powered by tagging specific. Yeah. Oh, this could be trouble. This could be trouble. Release download Linux. Maybe, I mean, they released it on Codeplex a while ago, but they just put it on GitHub, I believe today, maybe late yesterday. Oh, that's trouble. That's trouble. All right, Microsoft. It goes to your releases page, but your releases page does not have releases. Download and unzip this file. Of course, it's not clear where to get that file. If I search for that file explicitly, if I search for that file, there's some websites that might have it or might be malware. Alright, but is the release probably just a particular place to pull down? Use common output, simplified build path, yada 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 yada. There's 2 closed. It's stable code. I imagine that's just like you're going to download a commit. Oh no, because it's already been compiled because it's the binary release. That's a bummer. I'd like to sort this out a little bit more. Oh boy, oh boy, oh boy. All right, is there something obvious I'm missing? That would be pretty silly. Okay. It says the setup. All right, because I don't want to have to build it myself. That is nominally going to be a lot more work. Let me just CNTK release GPU Linux binary. Maybe I have to go to the codeplex website. That might be what you have to do. Got examples here, but that's like the data itself and learning it. We're gonna hopefully get to one of these points. That'll be good. Is there something really obvious I'm missing? Someone yell at me if I am. I don't believe. Set it up in your machine. Binary download and configuration. Unzip from release page, but there's no releases on the release page. I'm betting that this was copied over from something on codeplex, and maybe these have changed. This information has changed a little bit. That is my guess. Is this on the wiki? No, it's supposed to be just different releases. Oh. Binary download. See for the current documentation, downloads. Recommended download, other available downloads, Windows, Linux. So that's a December 9 version, which involves CUDA 7, which maybe that's okay. Yeah, so here's essentially the same instructions, but on their codeplex page. So that just hasn't been updated yet. I don't know if like I assume they must be planning to update their releases. That would be really nice. I guess they're just not there yet. All right, that's fine. That happens. It's gonna slow me down a little bit. All right, so in that case, we're gonna try to build from source. So that's what we got to do. Set it up on Linux. Let's do it. 64-bit installation of Linux. I have that. C++ compiler. I think I have that. Fatal error, no input files, but I have G++. Yeah, 5.2. I have no idea if that's recent or not. Yes, I have G++. I have Git. ECML, I'm not sure that I have. I might. That's the AMD math library. AMD core math library. AMD makes computer processors. This is a popular core math library that they have. Arch Linux, what was I looking up? ACML. Do I have it? Based on i4. Oh, it's in the AUR? Really? Hang on. For Linux built with Intel Fortran. Really? This is surprising. Did they say how to check if I have ACML? Get the file from, oh geez, 5.3? What version is this? 5.3? Once you feel the file, I'm orphaning this package. Good luck. Oh, great. So this package has been orphaned. Or I just download this and I install it. Oh Gosh, it comes with its own like sudo install command. That's super dangerous. Really? Does no one else use ECML? Instead of ECML and C++? This is weird. Like in my experience, it's like I've seen it in a lot of places. So this is surprising. I really don't want to switch to Windows and do this. And I feel like if I have to do that, I'm just not going to. I'm not gonna look at this too much. Problems with ECML on Arch Linux, yada yada yada. So this is the dependency hell that is necessary to get things working. That in Theano, I think because it's a purely open source project and from the ground up has been built that way, that it was dead simple to install. All right, well, let's try to install ECML from source then. This is tempting, but this looks like it doesn't work anymore. Although this is up to date enough. How old is this? Last updated 6 months ago in July? You know what? We're going to try it. We're going to try ECML i4. So I have an Arch install helper. That'll help me out here. I want to install one package, of course. So it's been compiled with the Fortran libraries. I don't really care. That's fine. Unsupported package. Yeah, that's fine. Edit the package build. Let's take a quick look. Make sure it's not doing anything nasty. It downloads this from AMD with iFort. What do they actually do here? iFort 64-bit TGZ. iFort 64-bit TGZ. So it's doing the same thing. Okay. This will just install it for me on Arch, which is nice. Usual stuff. Okay. Looks good to me. Continue building? Yeah, do it. Type. Okay. And install. Yeah, I really like the Arch Linux user repository. Makes it super easy to start. Oh. Aborting. Make package was unable to build. Restart building? No. Failure while downloading. Failure while downloading? Really? Oh, maybe that's not the link anymore. That's the problem. G4chan. Oh, cool. Do I have iFort? That's another question. I don't. Do I have G4chan? I should have G4chan. I do. Okay. Alright, so we're going to use the G4chan version then. Although they recommend iFort, but whatever. That's hoot and handy. Zip. Oh, it's already built. So it doesn't matter. Int 64 versus non-int 64? Come on, buddy. Let me click this. Yes, AMD license agreement for your core math library. Derivative works, documentation, intellectualized property rights. I accept this. Maybe that's why I couldn't install it with the AUR helper. This is going to take another 30 seconds. We'll have to screw around. Okay. So why are there no releases yet? That is, I guess no one has built it yet. They just released it today. So it's not just quite there yet. And yes, I can't use the AUR to install ECML. What's next after ECML? Open MPI. That should be super easy. I might even have that installed already. I don't remember. OpenMPI, that's 1.10? What are they recommending? 1.10, look at that, look at that. Pacman-s OpenMPI, that's right, yeah. Read, looking for conflicting packages, do it, make it happen. Uh-oh, I need to update my cache. Oh no. Oh no. Come on, come on. Die. Alright, fine. Pacman-sy, OpenMPI. See if that works. Alright, hang on. sy, OpenMPI. Must be a new version out there. And 1.10.2-1 versus 1.10.1-3. So yeah, slightly new version of OpenMPI, which is nice. All right, and we have successfully downloaded our iFort, which means I'm still going to do this, but where it says, hey, go grab and download this, edit package build, heck yes, instead of going somewhere and downloading it. I'm going to use the file that exists already in my directory. CD downloads present working directory. Hey, /home /voxel /downloads / whatever this goofy thing is, and that's now the source. And how does it? There's like got to be a wget somewhere. I suppose I could even put like a file colon thing on there if it's going to do some wacky wget stuff, but that should be fine. Let's try that. Already installed, edit package build. No, it's fine. Continue building? Yeah. Error, not found in the build directory and is not a URL. Restart building? Yeah, I'll try that. Fine, it's not a URL. There. Now it's a URL. Don't edit the package build. Continue building. Unknown download protocol file. Alright. That didn't work. AUR install from local file. Like, I want to use this program as much as I can. AUR install from local source, maybe. That's what I want. Force, yes, fourth. Source, thank you. Use the source, use the source. Dot install files, install from local source, Yowert. No, I'm not, I don't want to, source, here we go. Make package, yada yada yada. Well, I'm not compiling from source. Well, no, I'm not. I'm in persistent local source repositories. Is that what I want? You'll pull remote repositories built in /temp. No, that's not what I want. Add the source files. Rebuild. Yeah, let me try this again. Like, I don't want to rehost this thing. How do I say local source? AUR? Is this Yowert based? I think this is just AUR. Yeah. AUR install from local file. That's kind of what I want. Offline installation of packages. There we go. Normal method, Pac-Man. I wish I could do that right now. That's just not gonna happen. No. Install from local source. Maybe that's what I meant. No, that's what I tried. I apologize to everyone. What are other people doing? They installed Windows and then Ubuntu and then Dockered. Okay. Is this also on Live Coding TV? This is not on livecoding.tv. I only stream on YouTube. I thought about doing it on Live Coding or like watch people code, but the focus shouldn't be on like the programming. Programming for machine learning is a means to an end. Okay. But still, how do we build this stupid package? Maybe it's time to give up and do exactly what they say here. And literally build it from source. Alright, I give up. That's what I'm going to do. I've downloaded the file already, so that's good. Edit package build, no. Continue building, no. Give up, yes. We're gonna expand that tarball. Let's go into ECML. Did it not? Oh, it doesn't even. Oh. That's kind of annoying, but whatever. And then there's just a big bang and installation script. Type, as usual. Yes, here's the license that we read earlier. Yada, 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 yada. I can't sue them. They can do anything they want to me, except /decline. That's interesting that it's not yes/no. Kind of cool. Where do you want to install ECML? Press return to use the default location. Accept the default installation path. See, I want to do that, but I guess I have Google and CUDA in my opt, so why the hell not? Sure. Let's accept the default path. Alright, so we're installing ECML. Let's see how we're going. HTML installation complete. Look at that. Incredible. Alright. Next thing. Add the following environment to your current session and your .bash RC. Alright, well for now, we're just going to do them over here. I will fiddle around with those later. Let me make sure I did that. I'm not sure that second one worked correctly. There we go. Alright, we have OpenMPI, that's all done. GPU specific package. Select not like package you need to set up GPU or CNTK. We would like to do that. Checking your GPU compatibility. Getting the latest driver. Okay. I have a CUDA compatible graphics card, yes. Here for older cards. Yes, older cards is definitely... Oh, well, I've used CUDA on my card, so that's not a problem. Select your card and download the driver pack from here. I already have... I'm pretty sure I have the things I need. Light DM? What the hell is this? Install the driver like and below. I'm pretty sure I have a driver for my card and I've used it. This is light DM business. Arch Linux, light DM. Let's see. What do we got? What do we got? Cross desktop display manager. That's not what I want to use. What? Install driver installation will likely fail. Oh, interesting. Open a remote terminal session in your machine to stop the Xwindow manager. Oh, so I'd have to like stop streaming to do this. Alright, so we might not be doing that, but that's okay. I don't think I need this light DM business. That's just getting the latest driver. I believe I have CUDA 7.5 actually. So I'm not worried about that. Install accelerated graphics driver. Select no if you already installed the latest driver. We're not gonna worry about that. If you decline the driver installation, you will get the following whatever. Light DM. Add the following environment to your current session. Alright, I believe I'm okay on this front, and I don't actually use user local CUDA. What's in my path? Also, how do you type echo? Apparently I can do that. Yes, opt CUDA bin. So I'm in the clear on that. Verifying CUDA 7 installation. Not too worried about that. CUDA GPU deployment kit. Okay, what is the GPU? GDU? GPU? Alright, just a small typo. That happens. Find the .run file for your platform here. Select the latest version. Download either. What? Install a GPU deployment kit. Alright. Let's nuke this stuff about things I'm not doing. Tesla deployment. A set of tools provided for Nvidia Tesla Grid and Quattro GPUs. They empower use, better manages. Supported on Windows, something, and Linux. Okay. So let me just see GPU deployment kit. See if someone's done that. CUDA GTK, Nvidia CUDA GDK. I think that's what we want. Oh, look at that. Nice and up to date. Just a couple weeks ago. That's great. Alright, so we're going to install the Nvidia CUDA GPU deployment kit using the Arch Linux user repository. We're not doing this silliness. In fact, that's less up to date. Oh no, that's maybe over here. Latest production release. Yeah. Alright, let's do that. Yowert. I don't recall what Yowert stands for. Probably yet another something or the other. That's okay. Bing. Not Bing like the search. This is for Microsoft, so that would be appropriate. Nvidia GPU deployment kit. Edit package build. Yes, it's always good to take a look at your package build to make sure it's doing what you expect. Nvidia Compute, CUDA 7.5, local installers, CUDA 352, GDK Linux.run, and we're going to run that file. Okay, that looks okay to me. Continue building. Yes, continue building. We got to download the file first. Then we're making some stuff. Compressing the package. Continue installing. Yes, sure. We got to do that. Okay, there we go. Continue with the... Now we're actually installing. Such is not a symbolic link. Is that bad? I think we'll be okay. That's CUDNN 6.5. Opt CUDA lib64. But I have CUDNN. It actually exists. Which is weird, because you would think this should be a link to this. Oh well. As it would be this. Doesn't really matter. I hope not, anyway. We'll find out. Okay, so that's installed. I think I've installed all the things I need. Installed GPU deployment kits. I did all that stuff. Recommend accepting default values. Cub. Get and install Nvidia Cub. Install exactly the Nvidia Cub version specified below to the specified path because it's being expected. Ugh, this hard-coded business. I'm not a fan of that. Alright, so I will download your specific version of Nvidia Cub. I'm starting to think that maybe I should have just used the CPU version to see what was going to happen. Alright, I'm in the downloads. Let's do it. Go grab it. It's just called 1.4.1.zip. I could use a better name. I guess I could have named it something else. Whatever. Alright, that'll be a few seconds. That'll finish up. And then hopefully we can get to something. And they're saying, yeah, unzip. Yeah, sure. Unzip this bad boy. Alright, good. Ooh, CD Cub. What's in here? Changelog text. Always good to read README, or at least poke at it. Cub project website, and yada yada. State-of-the-art reusable software components for every layer of the CUDA programming model. Device-wide primitives, thread and resource utilities. Alright, so when they were developing CNTK, they used this Cub library from Nvidia. So that's entirely fair. And so you have to install that if you want to use the GPUs. And we're installing everything from source because they haven't built a release yet, so that's how it goes. And good gravy, you just copy this thing to user local? Seriously? Is that what you're supposed to do? User local, and it's just gonna be like Cub? That doesn't make sense to me. That doesn't seem like the right thing to do. Although that's where it's expecting it to live. Okay, buddy. No such. Oh, right. Okay. Now my user local has Cub chilling out right there. I feel like this is polluting my system now. Okay, but we'll keep going. If you'd like to use CNTK to get the Nvidia CUDA, I have CUDNN. I installed that with Theano a while ago, so I think we're okay. Although, install exactly the CUDNN version specified below. You know what? We're not going to use CUDNN then. We're just going to use the normal version. Add the environment variable to your... Yeah, we're okay on that, I think. Optional OpenCV. I do not intend to use this with OpenCV. That's computer vision. That's a program that will help you extract and analyze, extract features from images and like try to read numbers on them. And it uses some machine learning things and some other things. I have a friend who's actually trying to use this to he's got a bunch of, I think, video or that, or just like pictures every couple seconds of when he went on a road trip. And but he was going different speeds the whole time, so he wants to like sort of turn this into each picture fades into the next, but he needs to have that fade at the correct speed. So he's looking for the mile markers in all the images, so we can like back compute his speed because he didn't have his GPS connected or whatever, and he didn't know. All right, or maybe you could use the sun and just try to estimate that. Anyway, that's a whole separate problem. OpenCV requires 5.5 gigs of free disk space. Okay, yeah, we're definitely not doing that. Getting the CNTK source code. If you plan to modify CNTK, you should really develop in testing. We're just going to go ahead and clone this. Does not provide you with access to the 1-bit stochastic gradient descent component. Seriously? Man. Alright, fine. Alright, so we're going to clone this bad boy. I don't really want to clone that in downloads. I would like to clone that in proj. Git clone. There we go. So there's a whole mess of objects. We're grabbing that. Ugh. I'm gonna give my voice a bit of a break here. Ugh. Okay. Ugh. There we go. Now it's going. Very good, very good. Should have posted this to Reddit too, maybe, huh? Okay, next step. We've got CNTK source code, that's great. I'm not going to worry about stochastic gradient descent because this has already gone on, or the 1-bit SGD, because this has already gone on a little longer than I wanted it to. Okay, building it. Go into that directory, CNTK, freaking, oh. CN capital letters. There we go. Fantastic. And cd build release, yeah, usual kind of stuff. cd really. Oh, make dir build / release - p. I see. Release - p. There we go. cd build / release. / configure. Now, this should produce a build of CNTK. If you would like get a debug build, use the following. Not particularly. I ensure the configure finds CUDA if installed, etc. Alright, so we're going to attempt to install. Generating whatever. Image reader will not be built. Cannot locate OpenCV. That's fine. I am a little curious. No, it's not in there. Okay. No, not the makefile. We're just going to go ahead with it. We're just going to do make-j all. So now we are compiling, which is, of course, the most fun part of any Okay, are we back yet? No, we are not yet back. Maybe. Okay, sorry about that. Compiling seemed to have crashed my streaming software, which is unfortunate. All right, where were we? And, oh, also it didn't work. So I don't know why that didn't work. Let's try to find out. Internal compiler error. Internal compiler error. That's all kinds of good fun. All right, but we're back now. What's going on? Waiting for unfinished jobs. We were trying to compile this thing. Program CC1 plus, whatever. MPI, so we're doing an MPI compile of best GPU business. Yeah. And that's where it didn't work. Internal compiler error. That's like the most unhelpful error I can possibly see. Maybe this is where it's helpful. Simple network builder.o failed. Let me just double check that they haven't. Oh man, I've also lost my Firefox. So it killed everything but itself. Xmod map. That's interesting. That doesn't normally happen. So I hope compiling this didn't like destroy my computer. I mean, that'd be weird. Okay, there it's going again. Much better, much better. Quick test of, yeah, well, maybe I shouldn't build with build type debug. Maybe that was, perhaps that was a mistake. Oh, no, I didn't. Did I do that? No, I didn't. In case you'd like to get a debug build, use this yada, 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 yada. Now you might say that, oh, well, I haven't actually done all this garbage that I said I was going to do. GPU, no, I don't need the GPU deployment kit. We're good on that. We are good on that front. Let's try this one more time. Let's see if they've got the binary installation. They've got a Windows from release page, a folder where you want to install CNTK, and then you got to download this Visual C++. Still no releases. That's very sad. Very, very sad. Well, but that's just like a specific place in the repository for a release. So that's what confuses me here. Mean 1-bit support, optionally configurable build option. Yeah. So we're trying this again. I might try switching to Windows, or I might say forget it. We'll see. If I can't get this to work at all, I mean, building from source is a huge pain in the butt. And it's not clear, like, what really went wrong here. Because internal compiler error, not particularly helpful. CNTK, build releases, .build, yada, 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 yada. Like, it seemed to be okay on all this other stuff. So it's like, what happened here between these two? Woo! There we go. Between these two lines that, damn it, that the first one succeeded and the second one didn't. And is that even going to be something that I can try to do? This uses ECML. Does this one? It does as well. Okay. You know what? Let me try making again. But I'm not going to use J. We're just going to say make. Or make all. So J is a way to invoke multiple processors or multiple threads when you're running make. So if you say like -J4 or whatever. I think that's right. Almost sure that's true. Jobs, yeah. Number of jobs run simultaneously. If there's more than one -J option, the last one is effective. It's given without an argument. Make will not limit the number of jobs. Yeah, so I might have consumed too many threads. So now I'm rebuilding it using just one thread. I should have set all, however, so let me kill that. I do want to make all. I think I have a 4-core, maybe an 8-core machine. I don't actually remember. Yeah, but that's not really important right now. I think, yeah, I'm pretty sure it's 4. Okay, now we're compiling again. Things are going okay over here. Takes a little time. I apologize to everyone. That's just the way this works, apparently, since we cannot install from binary yet. If I can't get this to work in the next like 20 minutes or so, or at least to compile and do something, I'm probably going to pause further interest in CNTK until they release a binary, which honestly that could be tomorrow they could release. Also, for those of you it's the first time tuning in, I usually stream Tuesday nights 6 p.m. Eastern time to 7, and been looking at different things. Like I said, TensorFlow and Theano. I'm probably going to look at convolutional neural nets with Theano tomorrow. We'll see how easy that gets. In the future, I'll probably be looking more at this CNTK from Microsoft, and I also plan to demonstrate some things in skFlow, which is sort of a higher level language or module to interact with TensorFlow. I tried it out and it's dead simple to use and install, so that was super good. All right, man. I wish I had a progress bar to know how soon I was, how close I am to being done. So compiling. So what's, how are the people, who's listening in here? Is there anyone from Microsoft who wants to tell me all the things I'm doing wrong? Or tell me that I should just try the Windows installation first. That'll be a little easier. I do run Windows 10. I dual boot between Arch and Windows 10. And Windows 10 has actually been pretty fine to me. When I'm doing development, I demand like 100% control of my environment. So that's what I've got set up with this Tmux business. And I don't have that for Windows, so that's why I don't use that. Okay, well, we haven't failed yet on this. And I can't see if it's made the same thing yet. Let's take a look. Let's search back in the history. It was like best GPU. Best GPU. Maybe best? No? None of those things? None of those things? Does this even work? Is this thing on? CNTK? Okay, that works. Search best. Best GPU. Alright. So it hasn't gotten to where it failed before. Hopefully we'll get there pretty soon. Or I could have just sold it. Say, use 2 threads. Maybe that'll be better. Do 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 do. Alright, let's take a look at their... What are they doing? This is just their news release. Download and install. Download it from GitHub. That's where we are already. Tutorial. I checked out their tutorial at the workshop, but it didn't talk too much about installing. It had these nice pictures. Yeah, so this is where they're claiming, this is where they're showing their impressive speedups. And so this is using 1 GPU versus, of course, 4 versus 8. And you might have just noticed this number is like almost 4 times this number. This number is not quite 8 times this number. There's this communication overhead. And they're showing that, well, if you use TensorFlow, you're not getting the 4x speed up compared to 1 GPU. That communication is very expensive. And Torch, well, Torch and Cafe are pretty good, but that's still costing you a lot. And that's true. In a lot of parallelization schemes, the communication is what kills you. I remember when I first learned MPI, like, so a lot of the programs that I wrote in MPI, they ended up taking longer in the parallel version. Just because if you don't write your code carefully, it takes the most time to get the input from this processor all the way over to that processor. You only want to do that when you absolutely have to, and you want to be as efficient as possible when you do that. And so Microsoft's thing for CNTK, they have this 1-bit stochastic gradient descent. So on a normal neural network, you're doing this gradient descent of a particular amount. Like you're probably using a float 32 that's 32 bits to say, oh, well, I need to go down by this much. I haven't read it thoroughly, but if it's called 1 bit, that just means it's on or off. So it's you either say, all right, well, this time our network was wrong, so we're going to tweak the value by this much. And probably this much is probably fixed by the learning rate. Or the, so it's just on or off. It's like, do we tweak it or not? We don't care by how much. So I imagine you have to be careful when setting up your network if you're doing something like that. I don't know what on the back end they might be doing to help with that. Like scaling your features would probably be very important. All right, how's this compiling going? Still going, still going. SGDlib. Well, that's exciting. /sgg.cpp. So how long ago did I see that in the previous one? Or, well, hang on, we got something new now. Train actions.cpp. Ooh. There we go. Again, I'm using Tmux, so I can search through my buffer here. CPP. There it is. Is this in the broken version? Yeah, it is. Okay. So we're getting closer. We are getting closer. Couple 5 screens, 6, 7, 8, 9, 9 screens until an error. So that'll be good, right? I apologize. I didn't know I'd have to build this from source and all this stuff. Let's see if we can see if someone else has released a binary. Microsoft CNTK. We're on the bleeding edge, however, since it was just released today. Microsoft CNTK binary. Yeah, let's just search that. Linux. Right. I'm really tempted to just try one from codeplex, if there is. That would that's really tempting now, just to try it and see what's going on. Oh, but they moved everything to GitHub. Downloads. That's ECML. ECML. Windows, Linux, download, install. ECML-CUDA 7, install CUDA, DPU deployment kit. You are ready to run. So I'm real tempted to just go and download this. Or even just this. You know what? Let's just download the simplest one right now. Just in case. This is a backup. We're going to save that file. Since the CPU version is supposedly very simple, download and unzip. Set environment variable. Okay. Make error too. Okay, so we got an error again. I think that's what we're going to have to do. Leaving directory, whatever. Recipe for target, whatever failed. LD returned exit 1 status. Undefined reference to Microsoft stuff. Interesting. Undefined reference to Microsoft stuff. NDL. Alright. So we're just going to use an old version from their codeplex webpage. Again, that's cntk.codeplex.com/releases. And we're just going to do the CPU version because that's the simplest possible thing. Because right now, I just want to see if this will work. And then I'll wait until they release a proper binary for Linux. Download it, unzip, but it's a tar file, so I'm not going to unzip, I'm going to untar. CNTK, yada yada yada, ECML 531, CPU only. Make it happen. Let's go inside there. What do we got? Demos, CNTK, whatever. Set the environment variable ECML FMA. I think it did. ECML FMA. It is 0. Yes, so I already did that. Okay. You're now ready to run CTK. CNTK. Look at that. That was 5 minutes for just the CPU for the old version. That's why do I even try doing the install from source? I should have known that was a bad idea. Okay. That's getting started. Getting started is done. Don't need to worry about that anymore. Examples. Click. Here's what we're going to do. We're going to do the mnist example because that's the standard thing to do. We're running the example. You got to download the files and then run mnist convert on it. You know what? Let's back it up. Let's use the data that they have with the system, and let's just see if that works. So this is some 2D synthetic data. Looks like we're using just 2 hidden layers of 50 nodes each. So you've got you'll have the input up top or at bottom, whatever you like to think. The first layer will have the input, which is going to be, it looks like a simple 2D image. Is that what it says? Wish there was a little more. Here we go. Details? No. Additional files. All right. Well, you'll have input, and then you'll go down into 50 nodes using, of course, the sigmoid instead of the rectified linear. Oh well. And those 50 will feed into another 50, and then those will feed into your output, which, given that they're using cross-entropy with softmax, I have to assume they're doing some classification. So it's like digits, but maybe this is fabricated data. Yeah, synthetic data. Or maybe it's like the iris problem. What kind of flower is this? Oh well. Setup. Compile the sources and generate the CNTK executable. Not required if you download the binaries. Huzzah! Run. CNTK. I bet that's not going to work. Not found. Demos. What do we got in demos here? Simple 2D. Cool. They don't actually tell me usage overview. There we go. Oh, simple 2D. Like, cause where do I actually get the, where do I get the CNTK? Where does that live, is the question. The actual executable file itself. Is it in here? I bet it's in here. Bin! Ding, 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 we found it! Huzzah! Excellent. Let's just see what happens when I run it without anything. Permission denied, because it's not marked executable. That's real funny. That's 770 CNTK. Okay. There we go. Exception occurred, no command line argument given. That is totally reasonable, but it did something. It did something more than nothing. We've got a few minutes left before I turn off the stream. I think the moral of the story is if you want to just play with CNTK, go to the codeplex site, get the old executable, and give it a shot that way. Alright, but now that we can run CNTK, I want to just see if this can even work. I'm just going to alias CNTK real quick. How does alias work? There we go. I always forget how alias works. One of those things. /home /voxel /download /CNTK, all this garbage. Bin CNTK. There we go. Now this should work. That didn't work. Where am I? CPU only, bin CNTK. I mean not found. No such file or directory. That's cute, given that it's definitely there. Home voxel downloads. That's interesting. /CNTK. Yeah, you're full of it, buddy. Let's try that again. CNTK. Alias CNTK equals. There we go. /CNTK. CNTK? There we go. Okay. Sorry about that. Getting a little goofy. We are there. I don't want to be in the bin. I want to be in demos. We're doing the simple 2D. Here we go. That's the README. That's what we're looking at right here. Let's take a peek. Linux, Windows, add this to your bin path. Yeah, we're not doing that. So you need to set up this thing called a config file. Error opening file. No such file or directory, which is cute. Oh, didn't mean to do that. Oh, didn't mean to do that either. There we go. Okay. See, we're gonna try this again. For some reason, that didn't work. /config. Where am I? Why is my... Oh, because that's too long. That's why. So it's expecting me to be in the data directory. Okay, that's the problem. It's a little weird. But whatever, that happens. Okay, and here... I want to actually be in config. I want to see what this... Let's take a look at simple.config. So this looks like it's telling you where's our script running from, where does its configuration live, which is this file, where does the data live, where are we going to put the output, where are we going to store the model. -1 for the CPU, yes. So which DPU we're using, or -1 to not use a GPU. Relatively straightforward. How precise do you want to get? So there's floats, there's doubles, there's shorts, there's longs. Longs are doubles. No, longs are ints. How many bits are you using? So this is probably 32, which is pretty typical for machine learning. What command? Simple demo train and then simple demo test. Presumably because we will train and then we'll test. standard kind of thing. What is our model path? So we're going to be saving it or running it from simple.dnn for deep neural network. And output node names scaled log likelihood. All right, so we're using the log likelihood. That's also the cross entropy. You'll see that called. So what is our actual demo train? You know what? I'm getting kind of impatient, so I just want to see what happens right now. CNTK with this config file. There we go. Let's see what happens. Ding! Okay, it's done. Look at that. Well, we ran something. Something was called Christ, something was called twice. Now what actually happened? Details. Yeah, that would be good. So calling CNTK says, okay, do this. You set up a config file that just says, hey, here's where all the stuff lives. And it looks like simple demo train here actually builds up our model. So I think in this case, everything lives in the config file, which is kind of cool because we're just using a simple network. We don't have to specify anything special. So let's take a look at this. Simple network builder. We've got 2 layers of size 50. Oh, we got, what is this? 2 inputs? We have only 2 inputs, I guess? Okay. 2 50 element hidden layers and 2 outputs. This is a slightly strange syntax to me, but that's okay. That's their use of syntax. Cross entropy with softmax, that's how we're training. Evaluation criterion, how good are we at actually predicting the output based on the input. We're using a sigmoid, and you could imagine, say, ReLU. I'm really tempted to just change that and see what happens. That's what I like to do with these things. SGD, stochastic gradient descent. So how big is our batch size? So we're going to look at 25 of these synthetic images at a time, and based on those error rates, we'll update all of our nodes. Dropout rate, we're not dropping out any nodes. So sometimes when you're running, you say, hey, don't use this node this time. Drop it out. We have momentum in addition to learning. So if you did well previously, or you did poorly, if you changed your value of your weight on that node previously, change it again. Change it more next time, or keep changing it that much. Parameter values for the reader. So this is, I think, just how we're reading data. UCI fast reader, mini batch mode, yada, 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 yada. Labels, test results. This is going to be the same thing, but just doing the testing instead of the model itself. Simple demo output. So let's, using a trained model. So what did we actually do here? Let's take a look at some of the output that it generated. Well, that's a lot of output. All right, so I read the config file, post-processing network, 7 roots. That's kind of cool. So yeah, these are all the bias and weight parameters. The H, the like activation function of the sigmoid. So it's showing you that, going through, defining those things. That's kind of cool. We get down to the cross entropy. 20 nodes to process and pass 1. 9 nodes, 20 nodes do not share the mini batch layout. Interesting. So it looks like it went through and built it. 603 records, so there's 603 synthetic images that we seem to have. That's great. What else we got going on here? Mini batch, sample scene 603. Like a 4% error rate, error prediction / sample, 4%. Sample, cross entropy with softmax / sample. Final results, sample scene 603. Yeah, about 4.5%. Perplexity. I don't know what perplexity means in this situation. That's kind of cool. All right, because we got this working a little bit, now I want to try a little bit. I want to try something goofy. I'm going to change sigmoid to ReLU for rectified linear. I don't know if that's going to be case sensitive. I don't think so, because Windows things usually aren't. I want to see if that even runs, first of all. Hey, it did stuff. What do you know? And it's the same? Maybe that didn't matter. Did I save that? I think I did. Simple tests. That's I'm in the data directory. Let's take a look at the output. Yeah, output. What's an output? It's all about the output, right? Simple.dnn. This is all stuff from December 9th. None of this has changed. So this has sort of already been existing. How can I make sure it both config files are nearly identical. That's multi-GPU. No, that's not what I want. All right, so that's just a synthetic thing to see, does it run at all? But let's see. So that was sigmoid. I think it's just using the previous config and it's not actually, is it building a new model now or is it just reading an old model? You know what? I think that might be good. That might be just a good place to call that one. I'm not gonna worry too much about what exactly is going on, what the hell it's doing. I'm not gonna be going for too much longer anyway, so. Running the example, right, this is MNIST convert. Is this gonna show me a cool picture? That's also a thing I'm concerned about. One hidden layer, we're gonna do compilation. Oh, this is showing off NDL. So it would be good if we could get this to work. MNIST dataset is not included with CNTK, but can be running Python. Of course, I use Python 3, not Python 2. Script will download all required files. Oh, that's kind of cool. Where are we right now? Oh boy. There we go. Let's go to image. That's not it. There are several examples of training data in different images. We are going to start with the MNIST. Example setup / image. Thought that's where I was. Guess that's not a demo. It's not here yet, maybe. Did I miss it? Maybe it's just not here yet? Text, speech. Speech. Alright. One last thing. Look at simple 2D, additional files. No. Okay. Alright, because they don't actually seem to have this MNIST convert.py in this particular directory, I'm not going to worry about that right now. Setting up the data and things will take longer than I want to stream for. Even if it's not that bad, it's kind of boring and uninteresting. At least attempting the installation is a little more relevant in terms of, oh, let me try this, let me try that. So, again, this is Microsoft's CNTK, Computational Network Toolkit, Microsoft Research, I should specify. It is this deep learning toolkit, and you specify your own little language or your configuration file if you're just using their sort of built-in simple networks. If you're building your own, you're going to use this NDL, what are they called again? Not the network description language. Something like that, though. That's sort of the own little scripting language for fiddling around and building your own specialized networks. I believe they're planning to release a Python version at some point, and maybe when they do that, and when they release binaries, I'll give it another try. But today, trying to install from source, that did not work out so well. Ran into problems, and they haven't released any binaries yet for their latest version. They only have the binaries from the old version at codeplex. So, but it's something to keep an eye on. I'll definitely be doing that in the future. But for now, I think that's enough for today. I've bored you guys enough, crashed my computer once, so that'll be good. So you guys have a good night, and I'll see you tomorrow. I'll be back with more Theano and convolutional neural networks, usual time, 6 p.m. Eastern.